Hello everyone, we are going to look today at how to solve equations involving logarithms. In some of the equations, the logarithm is already there. In other equations, we'll need to transform the equation and involve logarithms. I would like to remind you from the P1 part of the course that not always I need logarithms to solve equations. So there are some equations, as this one here, where logarithms are not necessary. In fact, there will be some equations, like this one, where we'll see common mistakes when students solve them and involve logarithms when they shouldn't. Please take a minute, pause the movie, and try some of these questions to see that you remember how to solve them. And here are full solutions to the questions on the previous slide. You can pause and zoom in. Let us look at the equation 3 to the power of x equals 81. I don't need logarithms because I know that 81 is 3 to the power of 4. So therefore, x equals 4. However, as we learned earlier, I can write x equals log in the base 3 of 81. But now I know that 81 is 3 to the power of 4. Using properties of logarithms is 4 log in the base 3 of 3, which is 4, so it's the same answer. However, if we have questions like 5 to the power of x equals 81, the only way we can do it is using a logarithm and then using my calculator to get the answer to 3 significant figures as a final answer. How about equations of this type? You can pause the movie and try yourself. So I will base my solution on the fact that if a equals b or left-hand side equals right-hand side, then log in any base of the left-hand side equals log of the right-hand side. So I can apply log on both sides. So log of 3 to the power of x plus 4 equals log of 5 to the power of 2x plus 1. Now, as a base, I can leave it without the base, meaning base 10, or later on I can add a base if this makes my calculation simpler. So, why I did this? Because one of the properties of logarithms tells me that the powers go in front of the logarithm. So, x plus 4 log 3 equals 2x plus 1 log 5. Now, it's difficult sometimes for students to see how to solve this equation, but I invite you to look at log 3 and log 5 as numbers. So, if I use from this moment those numbers, which I get from my calculator, it's going to be quite ugly, and then I need to carry so many decimals with me that I may make mistakes. However, I'm going to use this example now only to see how to solve it, and then I'm going to go back and work with log 3 and log 5. So think of, instead of log 3 and log 5, as those numbers. So your equation is 0.47712 x plus 4 equals 0.69897 times 2x plus 1. And now see, it's a simple linear equation. So you are going to multiply over the bracket plus 4 times 0.47712 equals 2 times 0.69897x plus 0.69897. See how ugly it is, but you see the solution. You subtract one of those so that you have x in one side. You subtract one of those to have the term with no x on the other side. So being ugly, let's look and solve this equation with log 3 and log 5, but it's exactly the same method. So what we've done is we multiply log 3. So log 3 times x plus 4 log 3 equals 2x log 5 plus log 5. Yeah, now x is here and here, so I'm going to subtract from both sides. Doesn't matter, for example, 2x log 5. So x log 3 minus 2x log 5 equals log 5 minus 4 log 3. Factorize an x minus 2 log 5 equals log 5 minus 4 log 3. So x is going to be log 5 minus 4 log 3 over log 3 minus 2 log 5. Now that's good enough to put it in your calculator to get the answer. And that's it. Or the question might ask, find x as log of a over log b. So then you need to work it out so that you bring it to this form. If the question would ask this, I would write x as log 5 minus log 3 to the power of 4, which is 81, over log 3 minus log 25. So it's log 5 over 81 over log 3 over 25. And that would be my solution in this form if the question asks that. If no, you just give the answer to three significant figure by putting this one into your calculator. So my final answer is 1.55 to three significant figures. Of course, you can always go back and check to see if your answer is correct. Take one moment to try this question. I'm going to start with the most common error. The most common error students will jump and write 2x log 7 times x log 4 equals x plus 5 log 3. Now I invite you to pause and see why this is not correct. So you have no mathematical basis to write this. You apply log on each of the two factors. Whereas when I solve equations, I need to apply log to both sides. Log 3 to the power of x plus 5. That's the next logical step. It's based on, let's look at the graph of y equals log in the base 10 of x. That if you have right hand side here and left hand side here, then log of the right hand side is this number here, and log of the left hand side is the same number here. And now I use step by step the laws of logarithms. And here is my solution. Let's look for a bit at inequalities. And let's look at 2 to the power of x smaller than 30 versus 0.2 to the power of x smaller than 30. Why are these different? Because the base is bigger than 1, the base, whereas here the base is between 0 and 1. Now think of the graph of y equals to the power of x. That's y to the power of x. Now, if the left-hand side is smaller than the right-hand side, that's your inequation. So left-hand side is smaller than right-hand side. Then your left-hand side is, let's say, somewhere here, or can be negative, doesn't matter, and your right-hand side is somewhere here. And see how the logarithm of the left-hand side is smaller than the logarithm of the right-hand side. So I can apply log in both cases. X log 2 smaller than log 30. Therefore, I can write that x is smaller than log 3 over log 2. In this case, think of the graph of y equals 0.2 to the power of x, and 0.2 to the power of x comes like this. So left-hand side is somewhere here, let's say, and right-hand side is somewhere here. So when you do log of left-hand side, it's bigger than log of right-hand side. So when you apply log, the sense of the inequality changes if your basis is between 0 and 1. So x log 0.2 is bigger log 30. Now let's look a bit at log of 0.2. Here is 1. That's a graph of y equals log in the base 10 of x. Log of 0.2 is negative. if you look at your calculator, is minus 0.69896999. So in this inequation, you'd want to find x and you want to divide both sides by log of 0.2, which is negative. Therefore, the sense of the inequality changes. So you get x smaller of log 30 over log 0.2. Now you might say, okay, but if I just apply log here without changing the sense, I get the same. So you get the same answer just by chance. It does not always work. Therefore, you always need to think when you apply log to an inequality, if the basis is smaller than 1, then the sense changes. And all logarithms of x between 0 and 1 are negative. My next examples involve logarithms. And here is an equation where logarithm is visible. To solve this equation, we use the following method. I bring left-hand side to a form of log of something and right-hand side of log of something, a single logarithm. And then a needs to be equal to b. And that's based on the fact that if log of something equals log of something, then we have a single value. If log a is here and log b is here, then a and b need both to be here. This doesn't work. I just do a short recap from last year. It doesn't work, for example, for y equals x squared. Yeah, if a squared equals b squared, that's a squared equals b squared, not necessarily a equals b. A can be here and b can be here, or they can be on both sides. But in the case of logarithm, it works. So I need to go back and write a single logarithm using the rules of logarithms. Therefore, I write that 2 minus x equals 5x, and that's how I solve it. 6x equals 2, x equals 1 over 3. Now, when I have equations involving logarithms, I need to think of the domain. And the domain is, remember the domain of log in the base a of x, is that x needs to be bigger than 0. A bigger than 0, a not 1. So I need to look at my x. In my case, 2 minus x needs to be bigger than 0 from the first logarithm, and x needs to be bigger than 0 from the second logarithm. So 2 minus 1 over 3 is bigger than 0, and 1 over 3 is bigger than 0. I need to check my solutions. Pause the movie and try this question yourself. Here is my solution. Don't forget that the domain, and you need to check that your solutions are within the domain. So I found two solutions.